It's a type of plant, a fern plant. Has over 1,000 chromosomes. That added fern can be found in high in the mountains and low in the valleys. Temperate deciduous forest, tropical rainforest. It's varied. The adaptability would be referred to as the chromosomal number, not necessarily the intelligence. The homologous chromosomes, again, homologs, every single somatic cell, right, contains both of the homologs. And they're known as diploid cells, or 2N. N is, again, the chromosomal number of that species. Haploid cells, again, we'll see those in the production of the gametes. Again, gametes or sex cells would be undergo meiosis, not mitosis. Only diploid cells producing other diploid cells, that's done by mitosis. Okay, so again, if I ask you for a short answer question, describe and diagram the typical somatic cell life history. And that would be it. If you just give me mitosis, that's only half long. Right? You need interphase. Hint, hint. Right? You need to incorporate interphase, as well as mitotic division. The interphase, again, about 90% of every single cell is in interphase, okay, throughout your body. This gap one, the cell grows to nearly twice its size. Let me see if I can. Yeah, these cells, yeah. This cell and this cell here, okay, look, as opposed to this cell here, anaphase, telophase, it grows to almost twice its size. When you're looking at these Tamar's lab, that would be a good thing to keep in mind. If you see larger cells as opposed to smaller cells, for instance, this cell here, it's smaller than this cell. This cell here most likely had just undergone mitotic division, and with this cell here. Okay? So again, when the cell grows to nearly twice its size, okay, and a deterioration of the plasma membrane, that's a key for the prophase. Okay? Again, you need to separate the cytoplasm as well as the metabolic machinery for two cells in one cell. Okay? So obviously you need a larger space for all of those endoplasmic reticulums to duplicate themselves. Mitochondria, they also will use their own DNA to replicate themselves. The Golgi body, lysosomes, ribosomes. Okay? The nuclear envelope will start to dismantle around to do away with the and expose the chromosomes. Microtubercular lattice starts to disassociate with each other. The astral rays yeah. I'll go over this and then I'll do it on the board. Only in animal cells, again, animal cells will have centrioles. Right? And again, only in animal cells will you see the astral rays. The astral rays will in an animal cell, animal cell, mitosis, the prophase, a dismantling of the nuclear envelope. You are going to start to see chromosomes in the duplicative form. I'm only going to put 3. The centrioles will duplicate. A pair of centrioles will duplicate. So 2 centrioles on either side. 2 centrioles on. These would be the astral rays. The astral rays. It's believed that the astral rays give some type of rigidity or structure when the microtubules are grabbing hold of the chromosomes from either side. We don't see astral rays in plant cells. Why? Right, yeah, right. That's the main. But more importantly, when you're, if you're a plant cell undergoing mitosis, you have a strong foundation or a cell wall to brace you. So, whereas you're bracing around the flaccid membrane, so these astral rays tend to give that rigidity to this animal cell. I'll talk a little bit more momentarily. Those would be the key aspects. I'm not going to do pro-metaphase. I'm just going to do metaphase. The nuclear envelope has been dismantled, and the chromosomes are aligned in the middle of the cell, hence meta. The spindle fibers will attach to either, on either side of the duplicated chromosome. These are known as spindle fibers. Spindle fibers. Spindle fibers are made up of the tubulin. Anaphase. This is what I was mentioning about the astral rays. The astral rays, it's believed, no one knows for sure, but the astral rays it's believed that it gives a rigidity or structure to a brace, if you will, for the flaccid membrane. When these chromosomes are pulled apart from each other, any separation of the sister chromatids begins anaphase. Again, any separation of the sister chromatids it ends metaphase and begins anaphase. And then telophase in an animal cell. Okay?
But only in the animal cell?
Yeah. I'll do the plant cell next. Reforming, this would be telophase. The cleavage fellow, this pinching off of the plasma membrane. And yeah, you're gonna see this in Tamar's lab with the whitefish blaster. This would indicate telophase, a pinching off of the plasma membrane. It's known as the cleavage furrow. And then you have cytokinesis. The two daughter cells. Two diploid daughter cells. From one diploid daughter cell. Okay, plant cell mitosis. This would be a diploid cell. No centrioles. You're going to see again prophase. Dismantling of the nuclear envelope. Start to form chromosomes. Duplicated chromosomes. These would be the cell walls. Okay? This would represent the nuclear envelope. Metaphase. Again, you will see spindle fibers. But we won't see astral waves or obviously centrioles. Anaphase. Anaphase. A separation of the duplicated chromosomes. And then okay, this is known as a cell plate. Okay. The cell plate. And it's made up of cellulose. Obviously, when the the cell plate reaches the original cell wall, right, that ends telophase. And cytokinesis occurs. You're not going to see, you may see nucleolus, but you're not going to see the DNA. But again, once the cell plate reaches the opposite cell, the walls of the dividing the two cells. So again, from one diploid cell, you're producing two diploid cells. And that's somatic cells. Plant cells and animal cells. Okay, centriole, in animal cell, obviously, centrioles. Migrate, they condense chromosomes. Nuclear envelope is dismantled. Prometaphase, mitotic microtubules attached to the chromosome. Metaphase, the sister chromatids separate or become, they don't separate, towards each pole. Spindle fibers attached to the chromatids from either side. The anaphase, separation of the sister chromatids. Any separation, it ends the metaphase and begins the anaphase. Telophase, nuclear envelope reappears. Cytokinesis. Cytokinesis is the actual, and again, the actual splitting of the cell. The cleavage furrow, some people say, call that cytokinesis. Other put it in the, so to keep it with my diagram, I'll put this in under telophase. The cleavage furrow appears. The actual splitting of the cell. And again, these are all micrographs of the animal cell. The astral rays you can see, and again, gives you some type of rigidity, while the spindle fiber is on the other side. These would be the pair of centrioles. And again, you can see the astral rays appear first. And then the spindle fibers in the metaphase. These blue would represent the actual chromosomes. Again, separation of the sister chromatids. You're gonna see that ends metaphase and begins anaphase. Any separation of the sister chromatid. And again, you can see the astral waves are given some type of support or rigidity to the cell. And then telophase, the pinching off of the plasma membrane or the cleavage furrow. And then cytokinesis occurs. And this is what you're going to see tomorrow. These micrographs from the whitefish blastula. These would be the astral rays. This would be the actual plasma membrane. And again, the plasma membrane. You're going to start to see the chromosomes appear. Dismantling of the nuclear envelope. Prometaphase, they add a condensing of the chromosomes. In the center would be the centrioles, right here. This would be one pair of centrioles and another pair of centrioles. On the back side would be the astral rays. And then on the back side of the other side of the centrioles would be another. These would be, again, the astral rays. And, the plasma membrane and the spindle fibers attaching to the duplicated chromosomes. This would be an anaphase, a separation of the sister chromatids. And again, the plasma membrane, you can see a little bit. The astral rays, and then the cleavage furrow. In a plant cell, again, these would be not stained like this, but the same structures. Okay? Under 400 times or high magnification. Again, this would represent a prophase, prometaphase, metaphase. All of these red structures would be the duplicated chromosomes, and they all are in the center of the cell, hence metaphase. Anaphase, ripping apart or separation of the sister sister chromatids. I almost said homologous chromosomes. And finally, the cell plate. Okay? You're going to see a very, very rigid cell plate. And that signifies the telophase. That you don't see in telophase, or you will see a cleavage furrow in animal cell. You're not going to see a cell plate in animal cell, and vice versa. Okay, we all set for the tomorrow's lab. I'm probably gonna begin the lab with a video. Mitosis. And then I don't wanna, you have the link with the video, at the end of my notes. But anyways, any questions? Okay, so we'll see you tomorrow, for mitosis lab. And, review. Did I answer all of the